I have been welding for 6 or 7 years. In particular, I've been getting paid to work as a welder in Bozeman. I do work for an artist, so we do a lot of decorative works, chandeliers, etc. So I've got quite a bit of experience in welding, specifically in MIG. I've spent 4 years being paid to do this sort of work. Now, I am not certified because that's not a requirement when you're doing decorative work, primarily. I've had a lot of experience with getting burned and injured by it sometimes here and there, which it's given me a little bit of how bad things can be. It's all right, it's not that bad. It's a pretty good setup, and it can be done safely, especially if you're employing safety in your execution of welding. So please advance. So there are several types of welding, some of which I've not listed here. We'll kind of go through them. TIG welding is the most difficult form, and that's why it's on the top of the list. Well, it's not really, it's not categorized that way. TIG welding is one of the most difficult and requires specialized equipment, and we'll talk about that on the next slide. Wire feed, there are two types of wire feed. Now, one type, the MIG welding type, can actually do both types of wire feed. So you have a standard machine that has wire inside of it, and it feeds through the gun. And if you have that machine already in place, you can already move wire through the gun and start to weld that down at the torch tip. You can put flux core in there if you'd like, and you can do it without gas, and we'll get to that as well. Gas torch is oxyacetylene, if you've ever heard of that. Gas welding, or is there another term for it? You just don't need to add filler if you don't have to. You can actually weld without filler. And arc welding, stick welding. This form of welding is one of the most difficult, next to TIG. TIG is the most difficult. Then it goes arc welding, then gas, then MIG. MIG is the easiest form of welding, and actually we have that equipment here. So conveniently, you all will be able to get to learn the best and easiest way. Please advance. So, to explain TIG, I'm just going to kind of go into a brief interview of each of the types. But first, welding is a form where basically you're trying to take two pieces of material and you're trying to join them by melting. Now, that is different as opposed to gluing. You can glue two sheets together, or you can use other adhesives, etc., epoxies. You can glue two pieces. You can braze or solder, which is melting a third material onto two pieces, and then it will like suck or wick into the gap and join them like soldering does. Welding will melt both base pieces. That's part of the process definition, is that it is a melting process where the base material is melted to join. Okay? TIG welding is the most challenging because you have to use one hand to control the torch, which makes an electric arc here with a tungsten tip. Now the tungsten tip does not melt, and that because it's tungsten, it has a very high melting point, and so the tungsten tip does not get consumed. It just stays there, making an electric arc, while gas comes through to shield the material. And with your other hand, you grab a filler rod and you feed it into the material while you maintain a gap with your right hand. So you're doing two things at once when you're moving across. And there's also a foot pedal you get to move back and forth to try and change the amount of power. It turns out to be one of the most difficult forms, but you can do some cool stuff like welding pop cans together, which pop cans are so thin they just melt away. Anyway, please advance the slide. This is MIG welding. The type we have. The basic idea behind MIG welding is that you have a wire being pushed through your nozzle or your gun. So the wire comes through the nozzle and is jacketed by gas. So gas will come through and it will blow around and jacket the wire and shield the metal from oxidation. So the wire comes through under high current and it touches the base plate, which is grounded, and the electricity melts this wire right at the weld front, or the tip, right where the liquid pool is, and as soon as the high current gets there, it melts that wire. So then, as you pull the trigger, the wire starts to feed, gas starts to feed, and then electricity will be turned on liquefy that metal pool, and you can drag this across the surface. Well, I mean, you hold it above the surface, and it will deposit metal while also liquefying the base pieces. So, again, this is the type we have. Now, if you advance one more, please. Here's another picture, a little different iteration of it. Here you can see the gun trigger. When you pull the trigger, wire and gas comes out again, goes through this diffuser, jackets the wire, and then touches the surface, liquefying it. And then that electricity and all the energy and the wire being melted and deposited makes a nice weld bead. And so you can push this across at about a ½ inch gap, and it will lay down a nice weld and weld the pieces together. So, next. This is actually a good cut view of the inside of the welding tip. So you can see this is our welding machine. Well, this is one of the ones that we used to use. You can actually tell this is the same sort of device here is present in the other room. It's just in different locations. So you have a spool holder where a spool of wire goes on, and it feeds through this gun, and it goes up here to the top where there's a set of feed rollers. Now the feed rollers pinch that wire, okay, and you put a little spring pressure on it like this, and it pinches that wire, and it also gives it electrical connection. So when you pull the trigger, those wheels start to go, and it pushes the wire through the gun and goes to this torch tip, which is shown here. The outside is not really insulated or grounded or anything. It's actually just thermally, actually it might be electrically insulated as well. It has a little ceramic insert inside this shield that keeps it away from the tip. The tip here, as shown, makes electrical contact with the wire again, just to make sure that you have good electrical contact at the end, and then the wire comes out. So when you pull the trigger, gas comes from the machine, wire comes from here, comes out the end, and it'll do your welding right there. Okay? Every time you use a welder, you're going to have to ground whatever you're working on. So there's a path for the electricity to go from the gun to the ground. So you clamp either the ground, like the floor, or the table, or the thing you're trying to weld, so you can make an electric circuit. And we'll cover the other pieces of our actual machine we'll be using in the other room. So please advance. Here's another form. This is obviously acetylene welding, gas welding. Use a oxygen and acetylene bottle to make one of the hottest flames you can produce on Earth with pure oxygen and acetylene. And so it heats the base materials, and you can do this without filler rod or with filler rod. One major difference is that you don't need any kind of electrical connection or any electricity at all, so you can do this out on a farm or in the middle of nowhere. To shield the material from being oxidated, you sprinkle a flux powder. It's kind of it's powder stuff. You can just put it on there, and it melts and makes a nice protective coating while you're trying to melt the two pieces together. So the only thing I'm really going to say about this is with an acetylene chamber, acetylene is not stored as a compressed gas. It is stored in a sponge, and it's released from a chemical process. And so if you open the valve on an acetylene tank and withdraw more than, I think it's 30 pounds per square inch pressure draw off, it will, it's an exothermic reaction. It'll start to heat up, and then it actually can explode right in front of you. It will explode, and your whole shop will go down.
Okay, so if the tank ever gets below 30 psi,
no, if you ever open the tank to where you're drawing 30 psi off, it's kind of a complicated sort of thing. I'm not entirely sure how it works out. That's so you don't open the valve and, well, yeah, you just don't open the valve and draw off 30 psi or more. It'll explode spontaneously. Anyway, please advance. This is arc welding. One of the cheapest forms, but also one of the most popular, one of the most technically skilled types of welding. They actually use this for nuclear power plants, naval shipyards, construction sites. If you're building like a high-rise, you can use arc welding because it's really convenient and it's easy to get to and cheap. You have these consumable rods, and they melt from this tip down. So as you touch the surface with it, and you drag it along, and it shortens in length as you're going. So it's always like changing in length. It makes it very challenging. You have to maintain a certain gap. To protect the material, they use this coating which vaporizes and then makes a cloud of vapor that protects from oxidation, and that is left behind as a slag layer, and so really messy to clean up, not very easy. Tends to make the this coating tends to mix with the metal, and you get kind of marbly, which is not a good thing. It's pretty weak actually. Okay. So I thought I'd talk just a little bit about the dangers. Well, actually, there's quite a few dangers. There are several things that can hurt you in the shop, especially when you're dealing with liquid metal. So it should go without saying that these things are very, very hot. Okay, so 2,300 degrees is roughly the melting point of steel. You will get metal to glow white hot for moments after you're done welding. You can vaporize gloves by putting them on it. So very, very hot, so don't burn yourselves. You can get a sunburn at close range. So Ryan actually got a sunburn last week. We did some test runs or something like that. And he got a sunburn, so he's wearing a short sleeve shirt. So I'm actually wondering, do you have a long sleeve shirt? And Jim, are you, okay, you're good. And do you have a long sleeve shirt?
No.
Okay.
I'm gonna be a welding jacket.
We got a jacket in there.
Do you have it?
Yeah, we got only one though. So but yeah, you're gonna want to wear that jacket because it will sunburn you to the point of the worst sunburn you have ever had with only 5 to 6 minutes of exposure. So yeah, you will turn cherry red in only like 10 minutes if you're welding. If you have the.
Are you used to being outside in the sun all day?
Me?
Yeah.
Not really. No. It'll burn you even if you're used
It's
to
worse
it.
than sunburn.
It's a radiation burn. Yeah.
It's not like a sunburn.
It's not a regular sunburn. So. But anyway, so. You can also be blinded by it. The light coming off the welding arc is 2 to 3 times brighter than the sun. So you can actually put on a welding mask and look up at the sun, and it will be dimmer than the arc when you're welding. You can look up at the sun, and it's just like a little pale circle because of how dark these screens are. Heat burns, I've already mentioned. Oh, also, here's a very important detail.